All right. Chapter 3. All right, so now we're moving to Chapter 3. This is derivatives. All right, so the two main things you do in calculus is differentiation, where you find derivatives, and then integration. Okay, so this chapter is where we just learn to do differentiation, and we pretty much do everything because with this text, the early transcendentals, then everything is in this one chapter, all the derivatives. And then chapter 4, we have some applications with derivatives, and then chapter 5 is the integration. So, and then that's all of Cal 1. If you go to Cal 2, we pick up with chapter 6 and then move on a little while. Chapter 3, Cal 3, pick up with another chapter and then end the book. So that's kind of how it works. All right, so these first two sections that we'll look at today, 3.1 and 3.2, they kind of introduce the derivative. Okay, and it's good to go ahead and rather than just jumping in and learning the rules, it's good to kind of try to know what's really going on as far as with the limit and that kind of thing. So we always start with the definition and that kind of thing. All right, so introducing the derivative. All right, in this section, we return to the problem of finding the slope of a line tangent to a curve. This problem is important for several reasons. All right. One, we identify the slope of the tangent line with the instantaneous rate of change of a function. So remember before we talked about average rate of change and instantaneous rate of change. And to be able to do instantaneous rate of change, you've got to know the slope of that tangent line at a particular point. The slopes of tangent lines as they change along a curve are the values of a new function called the derivative. So the function that we get that identifies all of those slopes is called the derivative. All right, and that's what we're finding. If a curve represents the trajectory of a moving object, the tangent line at a point on the curve indicates the direction of motion at that point. Okay, so that's another application there. And we've got a couple of diagrams here. Okay, so notice, just remember a tangent line is a line that touches the curve in exactly one spot. And that's it. All right, a secant line would be a line that crosses a curve in two spots. Right? But to be tangent, it has to touch in one spot. So notice this tangent line here, slope of the tangent line and instantaneous rate of change are negative. So if the line is going down, then your slope will be down and over, so you've got a negative slope. Right? So that's how those would look. If I look at a point over here, like say somewhere around in there, that tangent line, slope of the tangent line and instantaneous rate of change are positive because the slope would be going up like that. Okay, so we got negative tangent lines, slope of tangent lines, and positive slopes. Okay, and then here's just a little picture as far as trajectory goes. If an object is moving along the curve here, then this tangent line gives you the direction of motion that's happening at each point. All right, any questions about that or anything? All right, let's see. Definition, rate of change, and slope of a tangent line. All right. Now they in the book, these first section, second sections, they kind of do this kind of differently maybe than other texts. So what they do first is they just start out with finding the slope of a tangent line at a point. Okay, so here we've got two different functions. All right, so we've got the slope of a secant line and then the slope of the tangent. Okay, so the slope of the secant line, if you can see this diagram here, let me make this just a little smaller. Can you still see that? Maybe? Okay. All right, so notice here's a point. All right. And then you've got all these other points here that make these secant lines that go through that. Okay? So the closer you get over here to where these points are closest, that's the closest you get to the actual line, right? That's tangent. So slope is just difference in y's divided by difference of x's. Okay? So f of x minus f of a, that would be this y value here, wherever it's at, minus the y value here, f of a. So y minus y divided by x minus a. That is slope. Okay? So just the slope of a secant, you just take the difference of y's divided by the difference of the x's. To find the instantaneous rate of change, or the slope of the tangent line, since we know what limits do now, then we take the limit as x, as this value here approaches this value a. And that will tell us what the slope of that tangent line is. Okay? Because if x is equal to a, what happens when x is equal to a? You're dividing by 0, it's undefined, right? But we still know how to do the limit as it approaches a now. And that's what we're doing. All right? So slope of the tangent line is the limit as x approaches a of f of x minus f of a over x minus a. All right? Questions about that? Okay. All right, so let's look at a couple of problems here. Directions say, use definition 1. To find the slope of the line tangent to the graph of f at P. Okay? And then B, we're going to determine an equation of the tangent line at P. And then C, we're going to graph. Okay? Now, all I'm going to do with graph, I'm just going to get pull Desmos up and graph it on it. I'm not going to do a hand graph, but we'll look at the graph after that. All right, so let's take a couple of functions. Let's say we've got f of x equals x squared minus 5. Okay, and I want to know what is the slope of the tangent line at the point 3, 4. So this is a point on the graph, and then an equation of the tangent line. Okay. All right. So following this first definition, all right. So the slope of the tangent line will be the limit as x approaches a of, so then we've got f of x minus f of a over x minus a. So that's the first definition that they gave us. Difference of y's divided by difference of x's. Okay. Now, notation-wise, this one is really not too bad. The other one sometimes confuses people with the notation, but what is f of x here? What is f of x? It's y, and it is x squared minus 5. So I just put this in the place of that. Minus, all right, what does f of a mean? Well, what is a at the point we're looking at? Is it 3 or is it 4? What? It is 3. It's the x value, right? F of a would actually be that y value, right? So really we could go ahead and put 4 in there. That's what I did. Okay. So I'm going to go ahead and change this to 3. That's what we should do as well. So a is 3. F of a is 4. Okay. So I'm going to do minus 4 over x minus a is 3. Any questions about plugging stuff in there? Okay. All right, so I get the limit as x approaches 3 of x squared minus 9 over x minus 3. All right, if I plug 3 in, I get 0 over 0, which is indeterminate. What can I do to that to figure out that limit? All right. What do we do? Sorry. Difference of squares. All right, so factor the top. Okay. And then the x minus 3's will divide out. So I get the limit as x approaches 3 of x plus 3. So now I can plug the 3 in, 6. Okay? So the slope of the tangent line at the point 3, 4 is 6. Any questions about that? So that is the answer to A. All right, that's A. All right, now B, I want to know an equation of the tangent line. All right, so how do I find an equation of a line? We can do a couple different ways. All right, the way that I normally do it is take the difference of the y's equals m times difference of the x's, which is point slope form. Okay, so start out with point slope form. We have a point, we have slope, so I'll do y minus y coordinates 4, m is 6, x minus the x coordinates 3. So 6x minus 18, add 4, 6x minus 14. Okay, so this should be the tangent line of that curve at the point 3, 4. Okay, questions about that? Okay, so I'm going to graph that up here with Desmos. Minus 5. All right, so there's the graph. Now our tangent line, y equals 6x minus 14. All right, there we go. Okay, so the point we're looking at here was 3, 4, which is right there. So at that point, that is where that line is touching that graph in just the one spot. Okay, that is the one line that is tangent at that one point. Okay. All right, questions about that? So we want to find the slope of the tangent line at the point -1, and then the equation of the tangent line. Okay. So again, if we use the same formula, slope of the tangent line is going to be the limit as x approaches a of f of x minus f of a divided by x minus a. So this is the limit as x approaches a. So again, a would be your x, -1. F of x is 1 over x minus f of a. All right, well, a would be -1 here, right? If I plug -1 into that, 1 over -1, I would just get minus 1 over x minus a again, which is -1. Any questions about plugging the numbers in? Okay, so I get the limit as x approaches -1, 1 over x plus 1 over x plus 1. Okay? If I plug -1 in, again, I get 0 over 0. Okay, so that indeterminate. All right, so what can I do algebraically here to work on this a little bit? Well, anytime you got a fraction inside a fraction, that is best to get rid of that. So how do I get rid of that 1 over x there?
Multiply both sides by x.
All right, multiply the top and the bottom by x, right? The common denominator. So multiply x over x. So let's see what that gives me. So I'll have the limit as x approaches -1 of 1 plus x over x times x plus 1. Okay, so don't distribute the bottom out. Now notice I have the same thing here. I've got 1 plus x is the same thing as x plus 1, right? So these will divide out. So this is the same thing as the limit as x approaches negative 1 of 1 over x. Now I can plug negative 1 in. The slope is negative 1. All right? Questions about that? So slope of the tangent line at that point is negative 1. Now, determine the equation of the tangent line. Start with point slope form. Okay? Plug in the point, negative 1, so y minus negative 1, that'll be y plus 1. Your slope is negative 1, everything's negative 1. X minus, the x coordinate's negative 1, so that'll be plus 1. So I get y plus 1 equals negative x minus 1. Y is equal to negative x minus 2. There you go. Okay? Questions about that? So now the alternate definition, which is similar to the one we'll use to find the function. I think here we're really still not finding the function. No, we're still just finding the actual slope. All right, so alternate definition. Average rate of change in f on the interval a to a plus h is the slope of the corresponding secant line. Okay, so then, so if you look at the graph here, you've got some value of x that's a here. And then if you just add some value of h to a, you get a second point. So rather than having x and a, you're just going to have a and a plus h. And it's really the same thing. You take the difference of the y's, all right, so this y value here would be f of a plus h. And then your x value here gives you f of a. So on the top, you're subtracting your y's, f of a plus h minus f of a. The bottom, you are subtracting a plus h minus a. Well, what is a plus h minus a? You can see this over here. If I do a plus h minus a, what does that give me? H, right? So all I got is h. Because if I subtract this one minus this one, that's what I end up with. Okay? Questions about that? Now, in the next section, we'll get to in just a minute, rather than having an a, we're just going to have x. So if we're going to, rather than knowing what, if we don't know what x is, we're just going to say if that's x, and it's the same formula. Okay? But here in this section, we'll go ahead and do a few more here with that, using this definition. Okay? So let's look at a couple more of them here. Okay, so let's see. Our directions now will say use definition 2 to find the slope of the tangent to the graph of f at p. All right, and then determine an equation of the tangent line at p. All right, we don't say graph anymore. Okay. All right, so f of x equals 2x plus 1. Okay, now before we work this one out, okay, think about what we've got here. What is the graph of 2x plus y equals 2x plus 1? What is that? What's the shape of that graph? That is a line. Okay, if you have a line and you have a point tangent to it, then the line that is tangent to that graph, what's going to be true about the slope of it? It's going to be the same slope. Okay, so anytime you've got a line, what you'll find is that the slope of the tangent line is the same slope as the line. All right. So what should the slope of our tangent line be? Should be 2. All right. Now let's go through the process though, because that's what we always do first. All right. So we'll go through the process, and then we'll but that's what we will see. All right, so our formula for this one, limit as h approaches 0 of f of a plus h minus f of a over h. Okay? Now, limit as h approaches 0. All right, let's plug this stuff in. All right, so f of a plus h. Okay? So first, what is a on this one? A would be 0. Okay? So 0 plus h, I'm just going to go ahead and plug that in. But this is f of a plus h, or 0 plus h. So what is f of 0 plus h? You take the function 2x plus 1 and plug this in the place of x. So that would be 2 times 0 plus h plus 1. That is f of 0 plus h. Everybody follow that? F of a is f of 0. That will be 2 times 0 plus 1. Everybody follow that? So here I put the top one, minus here I put the bottom one. Okay? So that will be 2h plus 1 minus f of a is just 1. Okay? And then h on the bottom. Everybody follow that? All right. 1 minus 1 is 0, so I get the limit as h approaches 0 of 2h over h. Then what happens to the h's there? Divide out, and I just get 2. All right. What's the slope of the tangent line? Same as the slope of the line. It's 2. Okay? Questions about that? All right. Now, equation of the tangent line. Y minus y1 equals mx minus x1. Write that out every time. Be sure you remember it. Okay. Y minus 1 equals, the slope is 2x minus 1 all right, y equals what did I do wrong there? X is 0, not 1. All right, so same thing. Y equals 2x plus 1. Okay. Questions about that? All right, let's do this one. F of x equals 1 over 3 minus 2x, negative 1, 1 over 5. All right, we'll do a quadratic one in just a minute. Okay, so slope of the tangent line the limit as h approaches 0 of f of a plus h. And let's go ahead and plug in what a is. What is a again on this one? Negative 1. So we'll say negative 1 plus h minus f of negative 1 divided by h. That's really what we're doing on this one, okay? Because we know what we're looking at a specific point, okay? So again, if I go over here on the side, f, I'm going to rewrite that as h minus 1. If I plug h minus 1 into that, I get 1 over 3 minus 2 times h minus 1, right? So this just goes into the function right there. Gives me that, okay? F of negative 1, 1 over 3 minus 2 times negative 1. All right. We can reduce that a little bit. All right, so this will be 1 over, all right, so I've got negative 2h, I've got 3, and then that'll be a plus 2. So 5 minus 2h minus, all right, f at negative 1, 3 plus 2, that'll be 1/5, and then h in the bottom. So that's what I have when I plug that in. Okay? Now, to figure out that limit, what do I do to get rid of those fractions? Common denominator, which is what? Got to multiply those together. 5 times 5 minus 2h. All right, so times okay, so that will give me the limit as h approaches 0 of, now if I multiply this times this, the 5 minus 2h's cancel, I get 5, minus, this times this, the 5's cancel, so I get parentheses 5 minus 2h. The bottom, always just leave it, don't distribute the bottom out when you have one like this with fractions. So I've got that. Okay. So what does that give me? That then now will give me 5 minus 5 is 0. Negative 1 times negative 2h will be 2h over 5h, 5 minus 2h, and now the h's will cancel. So now I can evaluate it. Now I don't get 0 over 0. So I have, here I have 5 minus 0, so that's 5. 5 times 5 is 25. 2 over 25. Okay? So what have I found? What is 2 over 25? The slope of the tangent line at the point, negative 1, 1 over 5th for this function. Okay? All right, so if I want an equation of the line that is tangent, I'll start with point slope form. So I'll say y minus 1/5 equals 2 over 25, x minus negative 1. So that'll be y minus 1/5, 225x plus 2 over 25, and then add 1/5, which is like adding 2 25ths or 7 25ths, yeah. All right, so y equals 2 25ths x plus 7 25ths. All right. Questions about that one? Equals square root x plus 3 0.12. Okay. So again, my slope of the tangent line is limit as h approaches 0 of f of a plus h minus f of a divided by h. Okay. All right, so a again is 1, right? So I could just replace those a's with 1s for this particular problem. All right, so now let's write out what f of 1 plus h is. I'm going to turn it around, h plus 1. And f of 1 is. All right, so if I put h plus 1 into the f function, I have h plus 1 plus 3, which is h plus 4, all right? Square root h plus 4. And then f of 1, if I put a 1 in there for x, 1 plus 3 is 4. Square root 4 is 2. All right? So that means I have the limit as h approaches 0. F of 1 plus h was square root h plus 4 minus f of 1 is 2 over h. All right.
So that would be like square root of h, and then it would just be not in the square root plus 2. Like it wouldn't be.
No, can't do that.
Out of that.
If it is multiplication, you can, but not with addition. Yeah. The h plus 4, that is one number, so you cannot break that part. Okay. All right, so now we've got a square root and a limit here. All right, so what did we do when we had a square root and limit before? What do we do to the top and the bottom to help us figure out what that is? Okay, multiply. Now the reciprocal of this means you flip it. Okay, that's it. The conjugate. All right. And remember, with this a fraction, you do the same thing to the top and the bottom. That's what gives you an equivalent fraction. So multiply the top and bottom by its conjugate, whatever's got the square root in it. So times square root of h plus 4 plus 2 over square root of h plus 4 plus 2. And again, just notice, this is an indeterminate form like it is. If you plug 0 in for the h's, you get 0 over 0. And by doing this, we get another function that is the same except at that one point, and that allows us to do the limit. So, all right, so multiply this out, so we will have limit as h approaches 0. All right, so on the top, there are conjugates. So there's no reason to FOIL it out because the middle terms will always subtract out. So all I got to do is say root h plus 4 times root h plus 4 would be what? Just h plus 4, right? If I'd say this times this and this times this, they're going to subtract off. Negative 2 times 2, negative 4. Now on the bottom, again, just multiply and don't distribute. So h times root h plus 4 plus 2 on the bottom like that. Okay? 4 minus 4, 0. Those go away. So I have now the limit as h approaches 0 of h over h times root h plus 4 plus 2. All right, and notice the operation here. That operation is multiplication. So I can divide those h's out. Can't do it with addition or subtraction, but with multiplication between the two factors, you can cross those out. So I just have 1 over this, so now I can plug in h for 0. So I get 0 plus 4 is 4, square root 2 plus 2 is 4, get 1/4. There. So 1/4 is the slope of the tangent line at that point. All right, and again, to find the equation of that line, do the same thing. Start with point slope. Plug in everything. And then that should reduce to be y equals 1/4 x plus 7/4. Okay? Questions about that? Okay? All right, just got maybe 2 more problems in this section, then we'll get on to the next one. So the only difference in these last 2 problems, we'll go ahead and do both of them, is the wording just a little bit and what they've given us. Okay, so here, they're just going to say, for the function and value of a, find this. Okay? Now, if we go back over here to our notes real quick, last thing. If I go down a little more, we have a definition. Okay, so here we go. The derivative of a function at a point. The derivative of f at a, denoted by this. So now, you see that little prime symbol there? Right, that means the derivative. Now, there's other ways of writing derivative. but for now, we'll just look at that one. That is given by either of the two following limits, provided the limit exists and A is in the domain of F. So the derivative of A at A is that, because that's what we've been finding. Now we're just calling it the derivative of the function at A. Okay? If the derivative of A exists, we say that F is differentiable at A at that point. Okay? Equals 4x squared plus 2x. They're going to tell us A is equal to negative 2. Okay? So that means that the derivative at A is the limit as h approaches 0 of f of A plus h minus f of A over h. Now, to plug this in, what is A? Well, A is negative 2. So f prime at negative 2. The slope of the tangent line at negative 2. Limit as h approaches 0. Now, f of A plus h. Well, that's going to be f of negative 2 plus h minus 2. Okay, so take this and plug it in for x, and you got two places here to plug it in for x. A little bit of algebra here. Okay, so let's go ahead. So we'll have 4h minus 2 squared plus 2 times h minus 2. All right, so I plugged h minus 2 in for the two x's. All right, here I got to square this binomial out. So remember, you do need to FOIL that out. You'll have a middle term there. So this will be 4 times h squared minus 4h plus 4. Okay, and that's just if you write h minus 2 times h minus 2, FOIL it out, you'll get that. Now we will have 4h squared minus 16h plus 16 plus 2h minus 4. So I get 4h squared minus 14h plus 12. All right, so let's see. So I've got that for that one. All right, what's the other one then? I need f of A. So f of A, I'm out of room there. Let's go over here. F at negative 2. Well, just plug in negative 2 in for x. So that'll be 4. It'll be 16 minus 4, which is 12. All right, so, and also that means that this point here is negative 2, 12 that we're looking at, right? If whenever A is negative 2. So it's the limit, as h approaches 0, of 4h squared minus 14h plus 12, and then minus 12. That's correct. Okay? So now this will be the limit as h approaches 0 of, so 12 minus 12 will be 0. Factoring h out of the top. H's divide out. So I have the limit as h approaches 0 of 4h minus 14, which gives me a limit, makes the limit be negative 14. So the slope of the tangent line at the point negative 2, 12 is negative 14. Okay? Any questions about that? Now, if A is 1/4, that means x is 1/4 at our point. If I plug 1/4 in here for x, I'll have 1 divided by the square root of a fourth. What is the square root of 1/4? What? 1/2, right? You just square root the top, square root the bottom. What is 1 divided by 1/2? 2. So 1 over root 1/4 is just 2. So the point I'm looking at there is 1/4 1/4, 2. Okay. All right, so the derivative at 1/4 is the limit as h approaches 0 of, right, f at a plus h. Okay, well, f at 1/4 plus h. So let's say a plus 1/4. Okay? That is, I'm sorry, h plus 1/4. A is 1/4. All right, so that's going to be 1 over the square root of h plus 1/4. Okay, that's all we'll do right now. All right, so let's put that in here. So I've got f of a plus h, which is 1 over root h plus 1/4, minus 2. All right, so any questions up to that point? Plugging all that in. Now I need to try to evaluate that. Okay, so 0 definitely doesn't work if I plug that in. I get 0 over 0. So what would I do first on that, you think?
Get rid of the square root.
Okay, get rid of the square root that's in the denominator maybe. All right, so because you got fractions inside fractions. So I would multiply by the square root of h plus 1/4 over the square root of h plus 1/4 first. Okay. So this will be 1 minus 2 times the square root of h plus 1/4 over h times the square root of h plus 1/4. Okay? So now we got that. Now still when I plug 0 in, I still get 0 over 0. Okay, so what now? Well, what did we do last time we had a square root in there? Multiplied the top and bottom by its conjugate, right? Multiply by the conjugate of the top. 1 plus 2 root h plus 1/4 over 1 plus 2 square root h plus 1/4. All right, so that gives me the limit as h approaches 0 of the top then now becomes 1 minus 4 times h plus 1/4. Okay, because remember the top is where the conjugates are. And I just say 1 times 1, and then I say that times that. Middle terms cancel. All right. Bottom, let's just go ahead and write it as h times root h plus 1/4 times 1 plus 2 square root h plus 1/4. Okay? Questions? Now it's going to work out, all right? Because on the what do I get on the top now? I have negative 4h. What is negative 4 times a fourth? Negative 1. 1 minus 1 is 0, so I just get negative 4h up there. And then that'll cancel with that h, and I'll be good. So let's do that. So I have the limit. So the top I get negative 4h. The bottom I have h times square root of h plus 1/4. 1 plus 2 square root h plus 1/4. H is cancel. Now I can plug 0 in. So let's see what happens when I plug 0 in. I get negative 4 over, all right, 0 plus 1/4, that's going to be square root of 1/4, which is what? 1/2 times 1 plus 2 times 0 plus 1/4, that is a fourth. Square root of a fourth is a half. 2 times a half, 1. 1 plus 1, 2. A half times 2, 1. So the slope is negative 4. Okay. Is that fun? All right. This is the hard way. Okay. Now we're going to learn a lot easier way to do these. Okay. But it won't be till section 3. But we have to go through the definition and seeing how that works before we learn little rules. Okay. So we will learn rules, but we want to get through a few of these first. Okay. That's the first section. Questions about that?